Imagine being taught the world your whole life, until you find out the map was lying. Not a tiny lie, a scale lie that makes Greenland look the same size as Africa. Today we're unpacking the map that lied and changed the world. Spoiler: it helped sailors, confused students, and, some argue, propped up colonial perceptions. We'll cover who made the Mercator projection and why, the math and the trick behind the distortion, how that distortion shaped how people saw the world, the backlash and alternatives, and what the map debate means today. In 1569, Flemish cartographer Gerardus Mercator published a world map using a new projection, a way to flatten the globe onto a rectangle while preserving angles. That made lines of constant compass bearing, rhumb lines, appear as straight lines on the map, which was a huge help for sailors. Mercator's innovation was not a prank, it was a navigation tool. Here's the trade-off. Mercator preserves shapes and angles locally. That's called conformal. But to do that, it expands areas away from the equator. The further you go to the poles, the larger land masses become on the map. So Greenland balloons to a gigantic size, while equatorial Africa shrinks on paper. Even though in reality, Africa is about 14 times larger than Greenland. Mercator didn't invent a conspiracy, but when a projection becomes the default world map in schools, atlases, and newspapers for centuries, it shapes collective perception. If northern countries look larger, more prominent, that visual bias seeps into how people imagine power and importance. Critics argue this helped create a subconscious Atlantic Eurocentric worldview. The key is context. For mariners plotting a steady compass course, Mercator was genius. For teaching equal area relationships or visual fairness, it's a poor choice. Over the 20th century, cartographers and publishers started to adopt alternatives better suited for world maps. In the 1970s and beyond, the map wars heated up. The Gall-Peters projection sprung from a political argument: show area fairly, even if shapes are stretched. National Geographic famously switched its world map from the Robinson to the Winkle triple in 1998 to reduce overall distortion. And now, campaigns like Correct the Map are pushing for modern equal area projections, Equal Earth, for example, to replace the Mercator in educational contexts. Maps influence more than opinions. They inform policy, textbooks, and even which crises get visual weight. Recently, the African Union endorsed campaigns to replace Mercator-style maps with Equal Earth maps in schools, arguing that decades of visual underrepresentation contributed to misunderstanding Africa's scale and global role. Important caveat: no flat map is perfect. Gauss proved you can't flatten a sphere without distortion. Every projection lies in some way. The question is, which distortions are acceptable for your purpose? Modern cartographers choose projections intentionally, not out of habit. Quick math bit. Mercator's vertical spacing of parallels is proportional to the secant of latitude. That's why spacing explodes near the poles. That's the mechanical reason Greenland grows so big on paper. So, Was the Mercator map a calculated lie? No. But it was a useful distortion that became the default worldview. And defaults matter. Today there's a global effort to fix our mental maps, to teach students with more accurate visualizations, and to choose projections deliberately. Maps don't just show the world, they help make it.